All right, there we go. So this is the current document that we have, and then I thought Jeff had shared. Do you have that link, Jeff? To oh wait, is this a taxonomy behavior? Yeah,
Yeah,
this is
we
it.
started putting together a spreadsheet or something, right?
Yeah, yeah, yeah. Okay, right. Um, the let me just give you an update on the threat modeling group because there is some tiny bit of overlap. The threat modeling group is working on a POC right now, and they are trying to capture well they're trying to capture like all the use cases, all the assets that you would need for like asset-based threat modeling. Um, no diagram information is going to be there, so you can derive a diagram from the model essentially. Um, and we've had participation from DaVinci, from Mirius Risk, from um, um, Kim Woods from Linden, and Izar, and a few other folks as well. So we've got a lot of expertise at that table. Again, they're trying to come up with a POC right now. And then for privacy, we're also coming up with almost like a taxonomy of different types of concerns. So it's not obviously going to be limited to Stride, but it's going to be a lot more comprehensive list of concerns. So not sure how that's going to turn out yet, but we're still working on it.
Cool.
Um, yeah, yeah, yeah. So as soon as we get the POC, I want to share it with this group because I think there is going to be a little bit of overlap with the architecture stuff that we're going to be working on, and how we describe the behaviors of said architecture. Um, so do we want to take a look at the taxonomy here? Is that where we want to start? Because I don't think we've talked about this as a group, or do we want to look, or do we want to go back and do something else today?
Uh, we we could continue to work on the taxonomy, but I feel like we all ought to try to agree on, like, what if we just assumed this was the complete taxonomy?
Hmm.
Then what do we do with it? Like, how is it, are we going to create diagrams? Are we going to, you know, do we have to have a way of drawing this? Is it, we, at one point we talked about, I think about modeling this as like a chain of behaviors,
Hmm.
but I think other people were more interested in more like boxes and what happens inside the box. Like, it's like there's like different ways of conceiving of this. Um, so I wonder if like we should just put a pin in this and say like, okay, let's imagine someday we finish out the whole taxonomy. I
Hmm.
imagine we're going to be extending it for a while, but I want to kind of see all my way all the way to the end, and like get one use case all the way through, and then we can go out and like flesh out the various pieces. Does that make sense?
Yeah, yeah. Um, so I kind of see this as, you presented a basically an either or. I actually see this as both, Jeff. So I think we should focus on a model that allows us to string behaviors together. But again, with CycloneDX, if we do it correctly, every object within the bomb, we should be able to reference. So if that behavior is contained within a component, well, we should be able to represent that. If
Mm.
that behavior transpires over a data flow, well, we should be able to handle that as well. So
Fair.
I think there's a lot of different ways that we can, associate a grouping of either sequential or parallel behaviors and just apply that to essentially any object in the bomb. if we do it right.
So it just means that every component, everything in the BOM has behaviors and connections between those components.
What's that? Every
So like, are you suggesting like we would just say like, oh, well, here's a web app. It has uh these behaviors and it connects to these other components which have other behaviors. And you
yes.
could see like which thread, like for me, like a web app has an attack surface. Each piece of the attack surface executes a set of behaviors, and one of those might be calling out to some other component which has its own sets of behaviors.
Hmm.
Um, that'll make sense to me. And I
Yeah.
think, are you also saying that like that web application might also invoke a component that does cryptography or something, or I don't know, a payment transaction or whatever. And so you could say within the architecture like that thread invokes that library to do some function.
Yeah, I wouldn't go down to the thread level, right? But yeah, you could absolutely model a behavior, an expected behavior that you should be looking for. Now,
I
how
just meant
that's
generally,
implemented.
yeah, I don't care about the thread. I meant like
Right.
in the APM world, they call it a flow, right? It's like what happens from end to end along the set of components that
Yeah.
get invoked.
Yeah, exactly.
Yeah,
I
you're
think,
thinking thread, not in the like computer science term, but just the term of like the
Well, in
flow
web
or like how things are
application,
linked together.
in a lot of environments, in a lot of frameworks, it actually is a thread. Like the socket spawns a
Yeah,
thread, and that thread executes the set of instructions on I don't know.
right.
It doesn't matter. So
But it's sort of a workflow or like
mhm, yeah,
something like that.
yeah.
right. Yeah, this is a little bit different than the formulation stuff that we had, because the formulation stuff um basically could describe any kind of workflow. Um, how you build software, how you train a model, how you bake cookies, right? It can describe kind of all that. Um, and but this is a little bit different. These things are just capturing behaviors, not necessarily the precise steps for how something transpires so that you can reproduce it. This is more about just observing certain behaviors, which is a little bit different type of pattern. Um, the do we want to do maybe like a do we want to do like maybe a tabletop? So Jeff's threw out the idea that let's just assume like this is the list. Um, let's do maybe like a very simple like microservice architecture, or a very simple set of lambdas, or something along those lines, where a thing responds over the wire, does some work, maybe calls out to something else. If we could model something like that with what we have here, just to kind of start fleshing out what the data model could theoretically look like,
Yeah.
would that be valuable?
Yeah, we could do something like WebGoat, not too complicated.
Well, WebGoat's a monolith, right?
Yeah, I don't care if, yeah, that's a fair point. It'd be better if we modeled something that had a front end and APIs and all that.
Yeah. Yeah. I mean, we can start small if you want to start with a monolith and just
It
um,
doesn't matter to me. I don't think it'll be very hard to use this framework to model stuff.
okay. So um how should we proceed then? I almost need a whiteboard. Do I have a whiteboard in my Zoom? Um,
Gotta be one in there somewhere, right?
yeah, it's probably deep inside of a menu somewhere. Um, do I have to stop my screen sharing maybe?
I actually don't see it in mine here.
I guess this meeting doesn't have a whiteboard. That's interesting. Was it
Could
in
you
the
just
share?
like throw a PowerPoint and share your screen? Something like that?
Yeah.
Miro, I have Miro here if you wanna.
Oh, wait, here we go. Yeah, I could use Miro. Yeah, let's do that. And then I'll just transfer this to something else. Okay, okay, so we had these things. Let's just draw I don't know, that sticky notes. Let's draw some shapes. Service A. Service B. And then we will have let's have a oops. Is there another representation for something? No, I'll just do another one, I guess. Oops. Come on. Okay, so two services, database. Seriously.
It's gotta happen.
At least I'm not demoing Miro. Oh, come on.
Oh. I think I was drawing something, I think in like Google Slides yesterday, and I did the exact same thing. I'm like, okay, I just want to move this thing, or I just want to type. No matter what it was, I was clicking the wrong thing every time.
Yeah. Okay, so we've got an API user, right? So this user, this could be an automated bot, doesn't really matter. This user is going to be querying these two services, and these two services interact with the database. Fairly simple, right? Horrible architecture, but we'll see if we can model it. So
this seems to me like a network kind of diagram.
well, we can model, again, we can model what's on the data flows. We can model what's inside each service,
Yeah,
right? So this will allow us to do both. We can have a different like grouping of behaviors for service A versus service B. So service A will have a set of behaviors, service B will have a set of behaviors. The API user interacting with service A and service B will also have different sets of behaviors. Does that make sense?
yeah. I want to see the case where you have service C and D running on one app server as part of one thing. And then there's
Okay.
two threads of execution inside that thing, one for service C and one for service D. But they're really, I mean, they run on the same platform. They're part of the same thing. They use a lot of the same components.
Mm-hmm.
And it's easier to model that way because then you have like one gateway that sits in front of both of those things.
Yep.
Or both in front of that dual thing. But I
Are you
think
saying
there's a lot of tools that model systems at this level, like all the APM tools do this automatically. And I'm more interested in the modeling what's inside these boxes, because that's kind of that's different.
Right.
Well, I think it's sort of like composability, where it's like, okay, you have this high level, hey, here's how those interact, and then you can zoom in on, you know, here's service C, whatever, and here's like the chains of behaviors in there that'll, go through this path to connect to the database, right? Or like do authentication or whatever
Well,
the
Right.
that's right.
various
Done
flows,
right,
right?
I think this is, it we don't have to, it's, what do I want to say? It's like, you can apply this at multiple levels all the way down. We don't need to have
Yeah.
this is the network level, this is the app level, this is, and like make those different. It's just, these are compositions of capability.
Yep. Okay. All right. We can model that as well. So how would we model? Let's see. We go back to, if we go back to
So like,
this,
are you asking about what goes on inside the service?
well, first we need to get to the service.
Okay.
Or do you
Does it-
want to, do you want to start with the service first?
I mean, the invocation of the service is pretty straightforward, right? Like somebody sends an HTTP request to something, or they put
Well,
a,
we've got to model, the HTTP request, and then we've got to model authentication and authorization.
right. So like, to me,
Where would that authn and auth-z be though? I mean, because the user is going to be sending those parameters, the service is going to be validating those parameters.
right. So yeah, those should be separate behaviors,
Right.
right? So that at the end of it, at the beginning of every connection, there should be like, I'm making a connection and I'm sending credentials, and at the end of it, I'm receiving credentials, I'm accepting a connection and I'm verifying credentials,
Right.
and then doing an access control check, and then like parsing a JSON document and sending, forming a query and sending it to a database, and all those steps that happen on a, a thread.
Right. So if we use authentication authorization, so if we want to model, regardless of whether we're modeling the data flow or we're modeling this service, we need to, if we're talking about authentication and authorization, then we need to distinguish, like, without making the taxonomy overly huge, we need to distinguish, well, what about authentication and authorization?
Yeah, every one of those security defenses has a bunch of attributes, right? Like authentication could be Kerberos, or it could be Okta, it could be a zillion things, web tokens. I mean, there's a bunch of choices there. Access control is the same way.
Right. So here we might distinguish, oops, why did I do that? So here we might distinguish authentication with, so if that is the taxonomy thing, well, this might be an assertion, right?
Mhm.
We will assert our credentials, and this would be validation, verification, or validate, whatever we end up
Yeah,
with, right? Same taxonomy item, different type of behavior.
yeah.
Um, let's go one step further. Authorization. Um, this is then going to authorization, and that's probably, verification as well. And if the user is asserting their authorization through like a jot or something, well, you still need to verify that, because blindly trusting jots is insane. However, if you're not, if this, for example, actually, this is a good case. Let's do this. So we're using a jot and we are asserting our authorization because it's signed, and
Yeah.
we are not revalidating that authorization.
But we
Because
verify the signature, right?
you verify the signature, but here's the challenge with jots. If you use jots without OAuth or anything like that, if the time to live is too long on the jot, like maybe a week or a month or whatever, I might have actually changed the authorization and you no
Yeah.
longer have access, but you still have a valid token, right? It happens all the time. Okay. So we're asserting our authorization using the jot.
But you could verify it, and it might be a
You could
legit
verify.
thing to say
Yeah.
like, hey, you didn't do that. That's a warning, right? Like,
Right.
there's the
Exactly.
risk that it exposes you to. But that's like the threat modeling part. Like here, we're just trying to say what it actually does.
Right.
Yeah. So I mean, I see APIs with no authorization all the time.
Right. Exactly. So what else does service A do? Then it does something internal.
So it's
It
parse the payload is probably the first thing most APIs do, right? Like you're gonna
right. Is that on the taxonomy? We got
it's
input
Posting it
validation.
somewhere.
I would say it's under parsers.
That's under risky behaviors.
Yeah.
Steve.
So like I'm only interested in modeling the behaviors that are potentially risky. Like I don't care if you're like, transforming a GIF, unless you're invoking the operating system to do it. But like if you're just
I
playing
mean,
around with the graphic, I don't like it. It's just not risky.
that's parsing, right? Because you got to read the GIF, transform
Yeah,
it, and then
but the question is, what are you going to do with the results of that, right? Like
right.
you parse the GIF, and then what do? You like it's a picture. It's not nearly as risky as like parsing a payload and then taking the data and putting it in a SQL query,
Right.
which is where we're headed here.
Unless it's an image of a password or something sensitive.
Oh, for God's
Right.
sake.
So
Right.
I'm trying to listen and learn before the revitalization of the formulation working group to see where the complementary nature of these things are. I don't want to derail the conversation,
Right.
but so if somebody could succinctly tell me who's the end user and what's the use case, what's being produced and who's interested in it, basically.
So this blueprint, like this imagine capturing the actual behavior of an application, all the things that it can do. And I'm using application generically. It could be an API, it could be a web app, it could be some other kind of software. I don't care. But we're trying to come up with a way of capturing the actual security relevant behavior of that application, whatever it is. And there are a lot of uses for that downstream. You might use it for pen testing. Now a pen tester has a map of what it actually does, and you can test it to see if it's got the right controls in place. It might be used for threat modeling, as we're sort of discussing here. It might be used for putting a risk in context and saying, hey, I got SQL injection on this, but let me understand what the database actually does. Oh, it's public data that is already accessible to anyone, so I don't care. Things like that.
So
Might even be used for incident response. If there's a breach, having a blueprint of the thing that got breached is how you guide your response and recovery.
okay. So now you had a third thought, but to build on where I jumped in and I guess Andrew's, build on Andrew's point, which is you can't, if you're modeling, you're modeling. You can't say, well, I'm discounting this because it's not in the traditional classical security realm or labels or whatever. Because regardless, the people are interested in this are like the PCERT team or internal people, right? This is not just like, it's not red zone, green zone, yellow zone, outside looking in. This is like things have gone badly, or I want to know where things go badly if these services are running in my enterprise, or inside something, right? And they're handling spine sensitive data. Everything is a security risk I was going to ask what the definition of service was, because microservices, and what the service can have multiple services, multiple functions,
Yeah.
multiple behaviors depending on the
Any
input.
piece of code.
Yeah. So everything you have to treat everything as if you're doing it, you just model everything, and assume the beauty or the security beauty or the security concern, the either holder, because you don't know what it's handling. It's just an image to you, but these are scans of PDF documents that I'm running through an AI application that have sensitive information about my company.
Yeah, no,
You know?
that's totally
Yeah.
true. I think we got to prioritize here and focus on the most common, most likely, most
And,
impactful
and
risk.
I'll throw something out there for food for thought. No, I understand what you're saying, Jeff. Got to get through an exercise, but I think that if you're going to pick a simple example, treat everything as if it's a security concern or a risk concern, I would say. And then I would say that these discussions are really similar to my colleagues, many colleagues in IBM research, who basically are focusing on replacing coders and developers, and AI programs that can understand your code. They can go through entire code base,
Sure.
and they can explain the code in prose.
So that's great. And like,
down
I
to a
that's a
function down to a function and snippet level. So the tooling is there to describe these things, and that's kind of the direction. I'll just say that's the direction IBM's going in, is that we're going to run AI against our own code bases to describe the risks. That we don't intend to model it, because it's just like the model is the application itself. So I'm just putting that out with food for thought. So we're not gonna have somebody produce a model and examine a model. We're gonna go firsthand and have AI describe, they could actually create the model for us if we wanted to, but more importantly, we just want to understand the risks. We want to jump to the conclusion. I'll stop
Yeah,
there.
that's the right modeling use case for sure. But there are cases when people actually do need to understand the behaviors of the systems that we're talking about.
Yeah, but I'm saying
We
that
can skip
typically
over all that.
threat modeling is usually done from a point of view where, where you assume zones and, outsider and people on the outside and people on the inside. So anyways, you take
We're
an
not doing threat modeling. There's a different working group that's doing
you
threat
take an
modeling.
ant you take an ant threat modeling is coming up for a lot. I think you just referenced it, so you invited me maybe to say something, maybe, I don't know. But it's usually from a point
Yeah,
of
we've taken the approach that one of the aspects of the threat modeling group that I put my foot down on, and I have kind of everybody aligned on it, is that the whole out of scope aspect of threat modeling is exclusionary by design. What is out of scope from my team may be in scope for another team,
right,
right? My
exactly.
team doesn't do network or data privacy. So what we're doing is in our data model, we're actually defining what the scopes are.
Right.
And that way you can look at the data, look at the model itself from one or multiple perspectives simultaneously. That's kind of where we're going. And the tools are antiquated because they don't have this concept, but pretty much all the tool vendors are kind of on board with this concept as well. Because again, we've got security people and we've got privacy people all coming together to develop the specification.
Yeah, it's the model view approach. It's, very, very
Yeah.
fundamental to modeling. Yeah.
Right. Yeah.
I think the underlying reason why this project is important is that I think there's a need to communicate this kind of architectural blueprint information to consumers of the software that are using it. So it's not just for internal purposes where I could just hand them all the code and run some AI and say like, well, there's no risks. But if I want to explain that to somebody external to my company, and I don't want to give them all the code, I need to have a way of expressing the architecture so that they can understand it and ask questions about whether it's useful for their particular threat model.
One of the examples that I would always give was log4shell, right? I might not have access to the third-party code, for example, because I purchased an application. But if I had a blueprint as a defender, if I had a blueprint that described the application, and I see that, oh, you know what, this thing is connected to LDAP. I also noticed that it doesn't have any input validation. I'm going to put a WAF in front of this thing with some rules to prevent, the log4shell exploit from, being able to exploit via LDAP, for example. I can do that with a WAF rule while the vendor is perspective. I think there's a ton of use cases for defense. Right now, bills of materials are not overly useful for defenders. They're not.
So
Right.
have you discussed incorporating, because I see service, to me, this, it still describes your service is kind of a descriptor of a generic descriptor of some type of function, and you want to describe behavior relative to a service as as one of your primary modeling, paradigms or whatever.
Mhm.
So have you thought about embracing, like extending or embracing open API, in terms of extending what you can do, just model instead of modeling just the APIs, actually, and just having a descriptor of the service, a free-form descriptor, that formalizing behaviors within an open API, saying here's a service, here are the endpoints, and here are the things it touches and it does, and some type of
Well, Open API is really too specific for our use case. Like a service in CycloneDX could be everything from GPS to Bluetooth Low Energy to like HTTP, right? It literally doesn't matter.
Well, I'm saying,
Um,
I guess I'm saying fundamentally, you've got to describe it. You have to describe you have to describe to a black box input, what the black box does, generally what the box does, and outputs.
Yeah.
And if you capture those three things, then you can call the black box a service, a thread, an
Right.
entity.
And that's
Yeah.
basically what we're trying to do, right?
Yeah.
We've got attack surface, so different types of attack surface
Right.
up here.
All I'm saying
Some
is
of
open
them,
API describes the inputs and outputs, and it just doesn't describe the behaviors. If it could be extended.
well, Open API is really focused on remote execution, but the attack surface can also be local, like file systems and
Yeah,
stuff like
true.
that.
Because I'm saying that you're breaking down. So that was because it's morely about service providers, like something as a service, cloud type of stuff, right? Platform as a service, function as a service, SaaS, all those things. But I'm saying that the open API does not necessarily need to be limited to, more of as a descriptor, more of how they describe things, rather than trying to say, anyways.
Yeah. Yeah.
I'm saying you're to me in my mind you're taking you're creating a service descriptor in my mind, and if OpenAPI has done a good job of describing the inputs and outputs, then you guys can do a really good job at classification and behavioral descriptions. So anyway,
Okay. Would somebody be willing to look at that? Because we also have to do the data flows and a bunch of stuff that are not services as well. So I'm not sure.
no, carry on. I just want to get my thoughts out there.
Okay.
Just carry
I
on.
will
You're in the right
I will
ballpark.
definitely take a look though. Let's see. That is a good point though. So let's see. We need to somehow indicate that this is an HTTP endpoint of some kind. Because we haven't really modeled, we haven't said that there's any attack surface right now. We've only said that this
Yeah,
thing
we gotta think of it.
asserts and this thing validates and parses.
Right.
We haven't actually
An
described the
endpoint that-
attack surface.
You could say endpoint, or
Yeah,
I mean, there's an endpoint : HTTP or something,
sure.
and you probably want to say like JSON.
Kind of almost like the open API thing where it accepts, right? endpoint. Do we want to get that granular though?
Yes.
Accepts.
Oh. Yeah, I think, yeah, absolutely. I mean, how are you gonna support the pen tester or the threat modeler if you don't say that it's HTTP, JSON, web token, whatever, like,
I think also too, so I think fundamental also is something that's or kind of like people don't think about is that where is this being, where is this being executed? Where is this black box being run on? So this is this is what I'm looking for exactly for ties to how we modeled the formulation stuff because we modeled
Right.
the platform down to the hardware, what things run on, because that's essential. I'll give you two examples. One is CBOM. So if what's being done is some cryptographic algorithm that's not quantum safe, you want to know that. Um, so it's doing some calculation, some data, it's applying some cipher or something, but you want to know, you want to know there's a threat because that can be broken, regardless if your endpoint's secure. If it transmits it, it's creating the behavior is creating data that can be broken.
Yeah.
The
so.
second
And
thing-
depending on what the algorithm is and what it's running on, you may not necessarily have enough entropy either.
Exactly. True. And a second thing, which comes from my days when I worked on Blu-ray disc encryption, um, which is the biggest threat the movie studio is worried about, was being broken at the processor level. That as I'm decrypting, I'm running a program that decrypts some encrypted content, and I'm worried that it's that the software itself one has been obfuscated in a way or broken apart in a way so it can be not exist in a single memory buffer or RAM inside of a CPU, one thing, and also that the again crypto is baked in a way so it's not necessarily block based, anyways. So extra things that you could provide as additional considerations that I think I've not seen anybody else provide in the industry.
Yeah, I think some of the CNAP providers are.
Like how is this, how is the data, how is this, how is where is this being, if there's data inside of it, and that's how it's being handled is one, but making sure that, that the processing or behavioral treatment of the data inside the black box is done in a specific way.
So my goal for this is to focus on capturing the application layer, at least for now. I think that's the big gap. There are some dependencies between the application layer and the underlying hardware that it runs on. But I suggest we focus on the application layer. So everything like, runtime language framework and up. So, JVM, app server,
JVM,
framework.
I just says applicable to a JVM. So yeah. Anyway, I'll leave it there. You model what you want, address your top use cases. I'm just providing you things that make what you're doing more
I
interesting.
think this ties very closely. So this is going to tie again. There's going to be some overlap here between the blueprints group and the threat modeling group. I think describing the runtime environments, because what we're trying to capture here is a little bit more abstract, but the runtime environments are a lot more concrete, and that's what the threat modeling group is going to be working on. I need to figure out how these two concepts interrelate, though.
I don't have a
It's not.
problem
It's not clear to me.
I don't have a problem with at some point modeling the rest of the stack. I just feel like right now there's the big gap that's missing is this application behavior gap.
No, I've said my piece. I will not disturb anymore. But these are things that go through my mind. So I'm just saying what's going through my mind of where this to me would be super beneficial to the people who care about this are people who really care about every aspect of how their data is treated through the entire system. And I'm just describing the ones who in my career have been the most concerned about that are, people creating $100 million movies and worried about that data being exfiltrated. So,
Understood.
right.
Not sure what happened to my Zoom there, but I am back. Can you hear me?
As well as AI
Yeah.
models, I'll point out, that's a big concern of ours now, people stealing
So,
our models.
Steve, I think we were modeling the endpoint, right? Like we've got an endpoint that accepts XML and JSON. Is that right?
Yeah, it accepts both of these. In this case, we're parsing XML.
And do you want to model the output side of that? Like
Yeah.
in
What do we do?
OpenXML, it produces
I was
JSON.
gonna do like file or something, right? Send it to
Yeah,
a
you could
file
produce
system.
a PDF or something.
Oh, okay,
That'd
okay.
be a cool service. Like,
So then do we want to, what do we want to do after this? What behavior do we want to capture?
so
So
I
after it does the XML parsing.
so what I like to capture in that thread is things that are risky and security defenses. So, you could clunk along here for a little while in your code and it's doing some stuff, calculations or whatever, I don't care. But
Mhm.
then it pulls a file off of disk, like a template or something, or it deserializes an object, or it does some things. They're not necessarily vulnerabilities. It's a risky behavior because it might have a vulnerability if you do it wrong. So
Huh?
that, and then security defenses, like you might see input validation or logging, or uh, maybe a data level access control check. Like this access
Mm-hmm.
control check is like a, broad API level one, but if you're doing it right, you should have lots of access control checks all over the place.
Yeah, yeah.
So all those kinds of things, I would want to see in this model. And I guess eventually we're talking about at the end of that list would be like a call to a date. Well, actually, maybe not the end. The call to that would be at some point you'd make a call to service C or something to
Yep.
get some data. And then, that data is going to return. Then maybe you call up a PDF library to format that thing. That might be risky. And then you actually have to send the response back. So you got to set headers, uh, create an XML or create a PDF response, I guess is what we're sending. So all those
My
behaviors here.
question is, sending responses, is that something that we're capturing here though? Is that a behavior that we want to capture?
I mean, I'm mostly thinking about
got
the web
network
context here where they're tied together, right? Like when you create a connection, you send a request and you get a response, but there are other kinds of APIs where you just, the response either might not exist or it might just be 200. Okay, worked.
Right, right, right.
Either
Okay.
way, I think I would put that at the end of the thing for most, web stuff. That's the last thing you do is you send the response.
Well, I think that, again, I'll say inputs and outputs. I think, I think you at your earliest because I heard some examples given. Anytime you output to a file system, to a device, not just traditional network output, they're device outputs. You work for the
Totally
device
agree.
output. So it's like file writes, file reads, move tensor matrix to GPU memory, move it to move it, if you have that access, if you have the ability, you can actually move things directly to hardware, So anyway.
Mm, yeah.
Yeah,
Am
you're
I,
not
am
tracking
I,
But
the
to me,
output.
it's two
yeah,
classes.
I'm piping the output to something. Yeah, exactly.
I think we should make it extensible, but to me, it's two classes of things here. It's security defenses and potentially risky things. That's what I want to know about.
I mean, sending any kind of output that comes from internal data is inherently risky, right? If you don't have the right things, like,
Depends where you're
hey,
sending it.
well, right, you're like, oh, hey, a random API person just asked me, literally do a SQL query, and now they're getting all my credit card numbers. probably want to have,
Yeah,
you want to make sure that doesn't happen,
yeah, it's
right?
exactly, you know, like financial companies, we cannot run one financial company's software on the same bare metal virtual machine because we can't, they can't share it. They don't want their stuff, they don't want any of their data in memory co-located with, you know, even if it's time sliced or whatever, with another company's data, right? So, yeah. Same thing for disks. They want to know it's an encrypted disk, you know, that if they're writing you to a scratch pad or a temp directory, they want to know it's encrypted, you know.
Right. I mean, that thing could be, yeah. Steve just added like data collected like PII. Like it could, service A could be querying the database for PII to send back, and that might be fine, right? And PII means all kinds of different things. Like an email address sometimes is PII, right?
Oh,
So
exactly. Yeah, it's like I said, you did the image thing. I said, what if it's a picture of my, you know, somebody took a screenshot of my password, you know?
right.
It's anything, any data going in or out of that black box. And you can describe classifications for, you know, for classic computing scenarios. You basically just look at if you're running this in a computer, what devices can you input and output to? You know, file system devices, you know, local DLLs, APIs,
Sure.
things like that.
Yeah, I'm trying to think how we should handle the runtime environment too here, Steve. A lot of that discussion was about the runtime environment. I feel like maybe there's a way to just say, hey, here's some assumptions we're making about the runtime environment in this architecture. Uh, I don't know. I guess I'm trying not to model the whole system all the way down to the bare metal because it's too much.
Yeah. There's two concepts that CycloneDX needs to be able to support, and we're not going to talk about them in this working group. It's too much. But the two concepts are what are the prerequisites for a piece of software to run? For example, it might require Windows 2000 and later, right? And being able to describe that in a machine readable way, or you know, a specific version of the Linux kernel or a specific version of GTK. So that's one set. What are the requirements in order for something to run? And then what are the actual runtime environment? What is the actual runtime environment? Which are related but entirely different things. We need to be able to support both in the next version, but we're going to be doing that outside of this group. Because the behaviors, for the most part, they're not going to change, right? If I deploy it on AWS or Azure, I mean, the behavior of a service that I create is going to be the same.
Well, the intended behavior will be the same. It might be, you know, if you've got ROT13 crypto that in AWS, like, I don't know. But I think it's
Yeah.
fair to model the focus on modeling the piece that's the intended behavior. Yeah, and then capture the
Now,
rest as like assumptions or something about the running environment.
right. Now we've got, let's see. Oh, that's not what I wanted. Okay.
There's no winning.
What's that?
It's like there's no winning. You just keep selecting the wrong things.
Seriously, I'll eventually get it right.
But
So
you can, I'll just say you can use MBOM as a fallback, reference MBOM for describing what you were saying earlier, Steve.
yeah, that's true. Yeah. So I kind of see this as right now we've been talking about these things all happen in sequential order, right? One thing happens after the next.
Yeah,
Software very rarely actually does that. Right. There's always sequential and parallel execution of something. Do we want to be able to capture that?
it's really tricky. A lot of modern web frameworks use promises and async kinds of threads. Up until about, I don't know, 5 or 6 years ago, I would have said like, yeah, most is like single threaded stuff. But yeah, now it's much more complicated. Which means that the order of some behaviors isn't guaranteed.
That's true.
Um, I think I would leave that up to the tool that captures this stuff, and just have some way of supporting alternate timing on these behaviors. Like one thing we could do is we could just say, this is just a bag. You're going to collect all the behaviors and put them in a bag inside that service that says, for that endpoint, this shit happened in some order. But it would be good to imply some kind of like observed order to the things that happen, or calculated order if you're like using static or something. Like you could maybe figure out what order things are likely to happen and just say, like, here's what we think is going to happen. We saw when we watched it that like these steps, like X, Y, and Z, happened in several different orders. So we're just going to put those in a box and say that like any one of those things could happen in any order, and then keep going. Does it make sense?
Yeah, it does. So what we've described right here is the happy path as well. Right? We've described, the fact that we use HTTP, the fact that we, accepted a valid type, the fact that authentication was successful, the fact that parsing the XML was successful. Do we want to describe the behaviors of the unhappy paths?
Absolutely.
Okay.
I mean, I like the way we do it. We watch a particular endpoint, and we watch every time it executes. Most of the time it does one thing, but a lot of times you'll see other stuff. It's interesting. Usually the first time you invoke a path, other weird stuff happens that doesn't happen on subsequent runs. Like you'll load a library, or so some other things happen. But we watch it over time, and then we merge all those threads together and say, hey, here's all the paths through this code. And look, it's pretty clear. Authentication always happens first, then access control. Then there's like 3 or 4 different things that can happen. But then it looks like every single one of these paths has a call to the database, or whatever. Like it ends up looking like these directed graphs. That's so we just calculate a merged directed graph across all the threads.
Right.
But doing it
Yeah.
statically, you could do something similar, just it'd be a little harder.
Yeah. What I think I'll do, we've got 2 minutes left. What I think I'll do is I'm going to throw this probably on. I, I need to see if I can even allow access outside of my employer to this. If not, I'm going to throw this probably in a Google Drawing type thing,
Yeah.
and we can just collaborate it on it there if that works for people.
I like using all these, actual behaviors to work out whether the language is rich enough. But I think actually the underlying language here, the syntax that we're talking about, isn't really very complicated.
I don't think it is either.
Like there's, I mean, in this model, we've got services and connections and behaviors, and that's kind of it so far, right?
Right.
And we need a way to say, we didn't do that, but we need a way to say that, there's sub services, multiple things inside something else. But I mean, it's pretty simple.
Okay. Yeah, I agree. It's going to take a lot of thought, but I believe the answer is actually it's not complicated.
Yeah. Components
There's going
call
to be a lot of commonalities.
components call components, and they do stuff.
Right. Pretty
That's
much. Done. Let's all go
Yeah.
home. All
Well, you
right.
just need to fill in a list of stuffs that they can do, and then and that's it.
All right. The next meeting is scheduled for the 27th. Obviously, that one is canceled. And then the meeting after that is on January 10th. So we're going to plan to meet back. The next meeting will be on January 10th.
Cool.
So with that, if I don't talk to folks, have a great holiday, have a great New Year. And
And we're still meeting Monday, right, Steve?
yes, that's for the formulation stuff, right?
Yep.
Yep, I'll be there.
Right, see ya.
All right, cheers.
Right. Yeah.
Have a great day.
Everybody.